Good day, everyone. Today I'll be going to review the derivatives of transcendental functions. So first we have the basic trigonometry and trigonometry formulas. We have some formulas. Sine quantity of a plus b is equals to sine a cos b plus cos a sine b, and cos quantity of a plus b is equals to cos a cos b minus sine a sine b. And the difference formula, sine quantity of a minus b is equals to sine a cos b minus cos a sine b. And cos quantity of a minus b, we have cos a cos b plus sine a sine b. And the double angle formulas from 1 and 2, we with a is equals to b is equals to theta. So we have sine squared theta is equals to 2 sine theta cos theta, and cos squared theta is equals to cos squared theta minus sine squared theta. And also, we're going to review and memorize derivative of trigonometry. So we have y is equals the derivative of sine x is cos x, and the derivative of cos x is equals to negative sine x, and the derivative of tan x is secant squared x, and derivative of secants or the derivative of tan x is 1 over cos squared x, and the derivative of cot x is equal to negative cosecant squared x, or negative 1 over sine squared x, and the derivative of cosecant x is negative cosecant x cot tangent x, and the derivative of secant x is secant x tan x, and lastly the derivative of cotangent x is equals to negative cosecant squared x. So let's have an example. Y is equals to sine 2x. Since we're working on the derivative of sine x, we know that the derivative of sine x is going to be cosine u du over dx. So in this particular function, let u is equal to 2x, and du over dx is 2. Is going to be 2. And if we're going to apply the formula for the derivative of sine 2x, sine x 2x, we have y is equals to cos 2x times 2 multiplied by 2, and this is the derivative for our sine 2x, which we can simplify as 2 is 2 cos 2x. This is how we use the derivative formula for sine 2x, and we use chain rule in this process. So let's have another example. Y is equals to tan 3x squared. So the derivative of tan u is going to be secant squared u du over dx. So y prime is equal to secant squared u times du over dx. We know that u is 3x squared, and du over dx is equals to 6x. So if we're going to substitute to our derivative formula, y prime is therefore secant squared u, which is 3x squared times 6x, or we can rewrite it 6x secant squared 3x squared. So this is our derivative function in this example number 2. So let's have another example. Find the derivative of f of x is equals to sine cube 4x. So we can rewrite this in form of f of x is equals to quantity of sine 4x to the power of 3. So this the modified version of our trig function where we are going to be using chain rule for our derivative. So f prime of x is 3 quantity of sine 4x squared times d over dx sine 4x sines 4x. So so we are already done with 3 sine 4x squared. So we just need to find the derivative of sine 4x. And we know that the derivative of sine 4x is equals to cos u du over dx is our derivative formula, where our u is 4x and du over dx is equals to 4. So we have cosine 4x times 4. So this is our derivative for sine 4x. And from our chain rule, our f prime of x is going to be 3 quantity of sine 4x squared times 4 cos 4x. So if we were going to modify this, we rewrite this as f prime of x is equals to 3 sine squared 4x times 4 cos 4x. Since 3 and 4 can still be multiplied, so f of x is equals to 12 sine squared 4x times cos 4x. So that's our the final answer. Thank you.